to be successful today. When else did we do exponent rules this year? Do you remember? The summer work. Yes, we did this summer work. That's when we saw exponent rules the first time. We're going to see them this unit, and then we're going to see exponent rules again at the end of the year. So we're going to spread them out throughout the year. These are some basic rules that you know. So let's start with a to the m times a to the n. What do I do when I have the same base with the m and the n? Add them. So I'm going to have a to the m plus n. Okay, so for example, if I have x squared times x cubed, what do I have? X to the fifth. Okay, that's an easy one. We're going to use that one next week more. Okay, not as much today. What if I have a to the m to the n power? Power to a power. Multiply. We're going to use this one today. So it'd be a, I can't write. It's a Friday. A to the m times n power. Okay, so if I have a power to a power, I multiply. So what's x squared to the 7th? X to the 14th. All right, what about the next one? A to the m over a to the n. Subtract. So a to the m minus n. So what do I get when I have x to the 5th over x squared? X to the 3rd. What's a to the 0? 1. So again, if I have x to the 0, 1. Anything to the 0 power equals 1, except for 0. What's 0 to the 0? Undefined, yeah. All right, next one. A, b to the n. Do you remember what I do with the a and b when they're both raised to the n? I kind of multiply, like n goes to the a as the power and the b, right? We say it's like distributing the exponent. So this would be a to the n and times b to the n. So same kind of thing. If I have x, y to the 3rd, how does that simplify? Yep, x to the 3rd times y to the 3rd. All right, now, same idea here, but now a and b already have exponents. So what happens when I distribute that p to the a and the b? Yeah, multiply then the m and n to the p. So I have an a to the mp power times b to the np power. It's hard to say n's, m's, and p's and b's. All right, what do I have here when I distribute the 5? I have x to the 10th and y to the 15th. And all right, now these last two, we're going to use a little bit today as well. What happens when I have a negative exponent? What happens? I have to move it, right? So this is really a to the negative n over 1. So when I move it to the denominator, what happens to its exponent? It becomes positive. What replaces it in the numerator? 1. All right, so I have a kind of complicated, more so, example here, because I want to make sure you know what's allowed to move and what's not allowed to move. In this example, what has to stay put? What does not move? 3x squared. Those both have positive exponents, so they stay in the numerator. The y moves to the denominator and becomes positive. All right, now the opposite, same rule, but opposite process here for the next one. If a to the negative n is in the denominator, it's going to move to the numerator and become positive. Remember, that's like a to the n over 1. So this one, this is tricky. I want you to be careful here. What term does not move? The 2. The 2 has an exponent of 1. That one's tricky. Don't get stuck there and move the 2. I know the 2 is glued to the b with multiplication, but the power on 2 is 1 and 1 is positive. So with the b moves to the denominator, right, and becomes positive. And where does the m go? The numerator to the top and becomes positive. Okay, do we remember those rules? All right, I'm going to give you like 2 or 3 minutes here. I want you to try those 5 exponent problems on the bottom part, right underneath the rules. And then we will check our answers. Do you want me to tell you the answer and then we'll check it if we need to, or do we want to just go through how to do it together? It doesn't matter. All right, for this one, when I have numbers, so it's all multiplying, right? So I'm going to multiply to start the 3 and the negative 2. That gives me negative 6. Now, what do I do with the n's when they're, like, have the same base? What do I do with their exponents? add them. So what's 2 plus negative 4? Negative 2. All right, but I can't leave my negative exponent. So it moves to the denominator, and I have negative 6 over n to the positive 2. Okay, so we want to get rid of those negative exponents. It didn't say that in directions. I should have said that, but does that make sense for that one? All right, the next one here. Be careful. This is 8 times x to the 0, not 8x to the 0. So what's x to the 0? 1, and what's 8 times 1? 8. That is different than if I had the whole quantity 8x to the 0. The answer is not 1 there. The next one, this one hopefully is not too bad. What's 18 divided by negative 3? And what do I do with these exponents in fraction? Subtract them, so it's negative 6c. All right, last couple here. D, what do I do when I have a power on the outside of the parentheses? Multiply, distribute it. So I get x to the 6 times y to the negative 12, then I have to move the y, right? So I'll have x to the 6 over y to the 12. Last one. Same kind of thing, only I have to do what do I do with the 4? You have to square it. So that's going to be 16a to the 6 over 9b squared. Oh, it's been a while, hasn't it? Are those okay? Even if you didn't get them all right, do you remember the rules, yes, Steven?
Why would you do like that instead of foiling?
Instead of what?
Instead of using foil, like.
There's FOIL is for plus and minus things. You don't have pluses or minuses here.
Oh, okay.
You know, here we're just. I mean, you can. So I know what you mean. So you're saying why don't you write it out like this twice?
Yeah.
You can, because that's technically what you're doing. But then you have to just employ all your other exponent rules. So you do 4 times 4, which is 16. A cubed times a cubed is a to the 6. See how that will give you the same thing? Yeah. What? The other one. It's just faster. Maybe not easier, but same thing. Okay, we ready to move on? All right, flip your page over. We're going to learn about new kinds of equations today. Well, not new kinds of equations, but a new way to solve some equations. So I'm going to show you, there's 2 examples here at the top. The first one, they look very similar. Is 12x equals 17. Okay. And the next one is 2x, 2 to the x, equals 8. They look kind of similar, right? Same setup. But here's the thing. We don't know yet how to solve either one of them. The bottom one, 2 to the x equals 8, you actually have every single tool needed to solve that equation. You just don't know how to put them together yet. So we're going to work on the bottom kind today. The top ones, we don't have any of the tools yet to be able to solve. You haven't learned enough to know that. So we're going to work on those in a couple weeks. So let's talk about how we would solve 2 to the x equals 8. All right, so I'm going to start with a simpler problem. This problem is 5 to the x equals 5 to the third. Now, these are both called exponential expressions. You know what an exponential equation is, or at least it should be in your brain because you did those in Algebra 1. This whole unit is going to start with exponentials. Now, what do we notice about this equation? Well, I notice, what do you guys notice about it? The 5s are the same, right? So we say both sides of the equation have the same base, right? The big number is called the base. So they both have a 5. That's a good thing. So let's use our process, analytical thinking here. If the 5s are the same, what has to be true for both sides of these equations to be the same? The exponents have to be the same. That means the exponent of x has to be equal to the exponent over here of 3, right? The exponents will have to be equal. Yes, does that make sense? So if the base is the same, in order for both sides to be the same, the exponents have to be equal to each other. You just solved that equation, x equals 3. Now, that was a really basic example, so we're going to make it a little bit more challenging here, but the idea is, our goal to solve these is we're going to manipulate the equations around so that I get the same base on both sides. So let's start with a really simple one. A, again, simple. I have the same base, right? 10 to the 1 minus x and 10 to the 4th. Since they have the same base, in order for those sides to be equal, I have to take the exponents equal to each other. Okay, if the base is the same, that means the exponents have to be the same. And then I solve the equation for x. So I subtract 1. I'll get negative x equals 3. And what does x equal? Negative 3. Okay, so if I wanted to check, if I put negative 3 back into the equation here, I'd have 10 to the 1 minus negative 3. And what's 1 minus negative 3? Plus, so it gives me 10 to the 4th. Is that the same thing as I have on the right? Yes. Okay, so let's try one. B, do I have the same base? No, but is there a way to manipulate the 9, I'll tell you, we're going to do the 9, I'll tell you why later, to make it so it has a base of 3. Not taking the square root. How can I rewrite 9 so it has a base of 3? That's 3 to the 2nd. So we are creating an equation so that we have common basis. This is called solving by common basis here. Is that okay for now? So now that the bases are the same, what's true about the exponents? They're the same. And you're done. Let's look at another one. We're going to do a number of these. Now, I have 4 to the 2x minus 1 and equals 256. So my goal is to figure out which or both, we might have to change both, of these numbers. I want to find the smallest common base between the two numbers, right? I will never take the 4 and make it bigger. I'm never going to make that 4 to some power. I'm only going to turn the 256 or 4 into a smaller number. Okay, does that make, once we see more, that'll make more sense. So, let's see. First of all, is 4 to any power 256? You might need to know your power chart or your calculator here. Okay, how about your calculator? Is 4 to any power 256? 4 to the 4th? So let's rewrite 256 as 4 to the 4th. This is where knowing your powers is going to be helpful. Because now, both sides of the equation have a base of 4. Because they have a base of 4, then I can set their exponents equal to each other and solve that equation. So I would add 1 and get 2x equals 5, and then divide by 2. So x is 5 over 2. If you wanted to, you could plug in 5 over 2 for x right here and double check that they're equal. How do you find out? Well, you just play around with it. You either have to know the powers, right? That's on your know your powers from yesterday, knowing 4 to the 4th, or just take 4 to the 1st, 4 to the 2nd, 4 to the 3rd, and just guess and check until you find it. All right, you'll get better at these the more we do them. I promise. You've only seen this for like 4 minutes right now, so it's not that easy yet. All right, 5 to the x plus 3 over 1 equals 1 over 5. All right, so obviously, what do you think your common base is going to be? 5, right? Okay, so I have 5 to the x plus 3. Can I change the right equation so it has a base of 5? Look back on the front of your notes. Flip your page over. What did we do with fractions there? Charlie?
85 to the negative 1.
Yes! Does that make sense? So when I had the negative exponent, that moved it to the denominator, so I would get 1 over 5. So now that I have the same base, I set the exponents equal to each other. And if I subtract 3, I get x equals negative 4. Do we see what we're doing here a little bit? So on these first 4 problems, I only changed one side of the equation. Okay, I changed one number. It was easy to find a common base. Now I'm going to have some problems where I have 243 to the x equals 81. Now, take your calculator for me real quick. What's 81 like squared? 6,000 something, right? So I cannot just change the 81 and turn it into a 243. So you need to figure out, either from looking at your Know Your Powers chart from yesterday or with your calculator right now, what base do I need to turn 243 and 81 into? What do you think, Stephen?
3.
3. All right, and some of you might have been thinking 9, right? So if you were thinking 9, it is going to be 3. But if you were thinking 9, what 9 to what power gives you 243? It doesn't. That's why 9 doesn't work. I could change that to 9, but there's no 9 to some power to give me 243. So that's why 9 doesn't work. So I'm going to change them both into a base of 3. 3 to what power gives me 81? 3 to what power gives me 81? 4. You see why I was thinking you weren't in powers yesterday? 3 to what power gives me 243? The 5th. So here's what I want you to do on the left. I want you to put 3 to the 5th in parentheses, because that's the 243. However, it still has what exponent that I didn't write down yet? X. Now we have to use exponent rules. What do you know about power to a power? What do I do with power to a power? Multiply them. So really that left-hand side is 3 to the 5x power. And I do want you to write all these steps down for now, because they're going to get harder. Okay? Now they have the same base, correct? So I can set 5x equal to the exponent of 4 and solve for x. X is 4 fifths. And again, if you wanted to check your work, grab your calculator right now. Can you type 243 to the 4 over 5 power into your calculator real quick? Good, check your work. Type it in. What'd you get? 81. Okay. All right, let's try B. I have 32 and 8 as my bases. Not alike. Any idea? 2. Okay, 2 to what power is 32? 2 to the 5th. So I have 2 to the 5th, and then I have to rewrite the original exponent of 3x. Then I set that equal to, how do I rewrite 8 with a base of 2? 2 to the 3rd. Okay. All right, so on the left, I'm not done. I have to multiply those exponents because it's power to a power. So it's 2 to what power here? 15x equals 2 to the 3rd. And then I can set the exponents equal. Don't skip the steps for now. When you skip steps when it's easier, you skip steps when it's harder, and then you make mistakes. Okay. Next week we will make it harder. All right, so I have x equals, what's that fraction? 1/5. Okay, we have 1 or 2 more. 2 more. Let's look at the next one. 6 to the r plus 1 equals 1. All right, well, first of all, is there any number I can raise to a power to get 6? Like 1 squared, 2 squared, anything like that? No. So, 6 is going to be my common base. What do I know about 1? What exponent always gives me a 1? 0. So I'm really going to rewrite the 1 as 6 to the 0 power. See how they have a common base now? Yeah. So I set the exponents equal. R plus 1 equals 0. And then what does R equal? Let's do negative 1. Okay. Right, the last one here. I have 49 and 1 over 343 as my bases. What number gives me both of those? 7. Okay, so D, 49, how do I rewrite it? 7 squared. Now I still have the same exponent, 2x plus 9. And then how do I rewrite this fraction with a base of 7? A negative 3. Okay, now I want you to be careful here. You are multiplying these two exponents together. So when I do that, I get 7 to what power? What is 2 times 2x plus 9? 4x plus 18. That is the exponent on the left now. Equals 7 to the negative 3rd. And then I can set those exponents equal to each other and solve. So I would subtract 18 and get negative 21, and then divide by 4. We're kind of following along, okay? It's a little weird. It's not too horrible, though. All right, there's practice on the next page. As you look, there's some exponents at the top. Look at the bottom half. Is there any problem right now? I want you to be honest with me. Like, are you guys getting it okay? You want to work, or do you want me to do any more of those problems?
I think I got that.
Okay. A couple people said do more, though, so pick one to do. Tell me which one you want. If you want to just work, then you can. But if you want me to do one or two more, I will for some of you. Which one? I. Okay, I did I this morning too. I'll do I. Start there. So I will then help you with J. So let's look at I. I have 1 over 6 and 36. What base do you think you're going to use for 1 over 6 and 36? 6. Okay. How do I rewrite 6 to what power to give me 1 over 6? 6 to the negative 1. Right? And then my exponent stays the same of 2m. And how do I rewrite the 36? 6 squared. Okay. Then before you move on, remember you're multiplying those exponents together because it's power to a power. So 6 to the negative 2m is 6 squared. And then you set the exponents equal. So what does m equal here? Negative 1. Now you can always check your answer. You can put negative 1 in here for x, and I'd have 1 over 6 to the negative 2 power, and you could check that on your calculator. It should give you 36. Is there any other one on that page, Charlie?
I don't think I have the right thing up here.
You do. Keep looking.
I'm not seeing it.
Okay, I'll look in a minute. But I copied it right. I printed this smartboard file. So
Oh, there it is. Sorry.
Anyone else? Any other problems you want to see? Or you feel a little better now? E, we can do E. And then I'll let you guys work. Here's E. Alright, similar to, we did one like this on our notes. 2 and 1. Which base do I need to change? The 1. What is, well, the base has to be 2, right? Because the base over on the left is 2. So 2 to what power is going to give me 1? 0. Okay. Then you can set it equal and solve it. Alright, what I'm going to do is I'm going to give you the next 8 minutes or so here to work. I'd like